In number 1, we need to assign the oxidation number. If you came to see the video, it probably means you got one wrong. And since we all have different compounds, there's not a lot I can do other than to give you the 3 checks or so that I find that are tripping people up. One is if you're doing a compound, and let's look at NH3, sometimes people, they'll say, okay, I know I need to do the hydrogen and oxygens first, so I'm going to put a +1 there. And then they'll go to do the nitrogens and they say +3. And I'm not sure why, but they tend to. They think it feels like a balance. So remember that this should actually be -3. Something's got to be positive and something's got to be negative. That's probably coming from the fact that a negative is on the left of the compound, and it usually isn't. But remember, it's not a charge, it's an oxidation state. So that's tip number 1. Second one is don't forget that if you're doing a compound like this one, MnO4-1, that when you figure it out, yes, you are going to do the oxygens first, but it's not, the overall charge is not going to add up to -1 or to 0. It's going to add up to -1. So that's my second tip. And my third tip is in simple ones like H+1, the oxidation state really is +1. There's not too much more than that. If you're an unfortunate person who got H2O2, remember that H2O2 has an unusual charge for oxygen, so start by assigning the hydrogen first and figure out the charge to oxygen. Alright, and one last tip. Don't forget if you have a compound like Fe2O3, when you're figuring it out and you're doing your work and you decide that this is going to be +6, that if there are 2 ions, you're going to have to split that up because the 2 of them have to add up to +6. And remember, it's the oxidation state of the individual atoms that matter, not the work that you do on bottom.